Okay, as I was explaining earlier, this represents two-gang switch. Two-gang switch in the sense that if, let's say, you have in the living area, you have what you call it, wall brackets and what recess lights or recess lamp. Which means you have to use how many gang switch is two. But had it been you have more than two provision for lighting. For example, you have rock lights, you have recess lamp, you have wall bracket. Maybe you have another lamp from, let's say, corridor or elsewhere. How many gang are you supposed to use? Four gang. Okay. So as such, that is how you select the switches. You have to know which outlet are you going to what operate. If, let's say, it's only one bulb for wall bracket, you go for one gang. We have one gang, we have two gang switch, we have three gang switch, we have four gang switch. So it depends on how many terminals are you going to incorporate in your circuit. So if, let's say, you have only two bulbs, let's say this is okay. Okay. Let's say you do parallel connection. We do series and parallel connection in electrical wiring as well. Even before that of battery, solar panel, and what have you, we do series and parallel connection. Parallel connection, as you all know, each bulb is independent to each other. But in series connection, they are connected or interconnected from one terminal to another, from one terminal to another. If there is breakage in the circuit, if, let's say, one cable from one of the bulb got disconnected, what will happen? All of them will lose contact. But for parallel connection, if one is faulty, the rest will continue working. Or if this bulb has blown, automatically the circuit will not be what? Complete. As such, it will affect the rest in case of series connection. So now let's go for parallel. You have only this N, and this is what common terminal. So this N will move straight to where? To this distribution board, which is this terminal. Hardly you will see neutral cable going down in your what? Connection. But rather you will see red cable going all over. Which means one is representing power. The second one is representing what? Common. Like this. Here to this place. This is our switch. If to say we are using two gang, this is first lamp and this is second lamp. Okay? So this is what one bracket. You have, let's say you have 1, 2 here and the third one is there, which means you have 3 bolts. So all of them will be connected together, just like this.
Yes.
To serve as what? Parallel connection. Which means their end terminal, which is neutral, will move straight to this distribution board terminal of what? N. Neutral. And this neutral is connected directly from where? From the 4. Whereas the remaining terminals will pass through the what? Cutout switch. 1, 2, 3. Red, yellow, blue. In the case when we are not following IE regulation, that's to say, from the main switch here, we do looping. 1, 2, the third one will move straight to here, upper terminal of what? Of our cutout switches. And meanwhile, we have to loop here. Because if there is power outage here, we can move to this switch. If there is power outage, we can also move to this fuse in this method. But if we are following IE regulation, which means we have to stick to this approach. Power or cable from red to this and to move straight to main switch, we have 3 terminals. Red, yellow, and blue on our what? Main switch. So which means yellow is connected directly from pole to cut out to what? To main switch. Blue and red, which means they are all connected together. Whereas the neutral is connected to where? To distribution board. So now, since we are using two gang switch here, which means we have here L, which is what the live cable. We have L1, L2, L21, L22. So which means the cable coming from where? From the DB here, live, will pass through this L. This has what? Power. Then, for you to get source or power to the second terminal here, or the second switch, what are we supposed to do? We have to link a cable from L here to this point. Why? This is L2. L2. We have L1 and L2. L1, L11, L1, L11. L2. Okay, this is L21 and L22 here.
Yes.
So as such, since you have tapped in power from here to this point, which means there's power in this. And when power is here, when you switch on here, switch here, it will pass through these bulbs and to where neutral, which is our circuit is what is complete. So as such, you have independent switching. Good morning. Good morning, everyone. One is representing, let's say, the recess lamp. The second one is representing which one? Wall bracket. And now if you have provision for more lamps, this is the way you are going to do. Instead for us to use two gun switch, let's say we have 3 lamps or 3 different bulbs. What are we supposed to do? We go for 3 gun. If we have 4, provision for 4, we go for 4 gun. This is how we do our on connection.
Yes.
The gang is to put on 4 balls.
If
One switch from the gang, 2 gang.
Yes.
To put on just 4 balls.
okay.
So that means we loop everything together
Exactly.
before we now bring one light or common.
Exactly. If you can remember, the last installation we did, if you can remember, we have in the living area how many bulbs? 4 recess lamp, right? 1, 2, 3, 4. So which means you bring in a cable to pass through first lamp and then fold it for just another lamp, and then fold it. It has to go in continuity. That is what I did here. Look at it. This one, I loop it. This, I loop it to this to the last one. So you have to do looping.
This is in parallel.
Of course, they are in parallel. But if it is in series like this, if let's say the bulbs, this is the first bulb, second bulb, let's say this is the third bulb. 1, 2, 3. If they are connected in series like this, which means this is N and this is what? L, which is what? Common cable. So if there is breakage here, since our neutral is connected here, the circuit will no longer be active. That is the implication of series wiring. And even if the circuit is complete, it will be what? Dim. Series connection in electrical wiring is always dim. If you go to hospitals, you will see, even if the voltage is normal, like you have 220, 230, but the bulbs will be what? Very dim. They were connected in series. But if you want to have bright illumination, you have to go for parallel connection. That is one. Secondly, faulty, or maybe one bulb is faulty, or one bulb is not there, or one bulb has blown, it will not affect the remaining bulbs. But if it is a series, even if the circuit here is complete, but this bulb has blown, it's not working, it will affect them. Why? Because current has to pass through it before going to the second one, to the third one, to the fourth one. Yes. You got it? Yes. Nice.